Hi, this is Dr.S.Valliammai of Chemistry Department and I belong to Dr. MGR Educational and Research Institute. Now in this I am going to deal about the Applied Chemistry 2 which belongs to the BSc final year students and the final semester. In the previous two parts I have just explained about the fuels and combustions. So in that certain general topics and the preparation of coke by beehive method. Now in this part 3 I am going to deal about the Otto Hoffmann's byproduct method and how the petroleum is refined. Now first let us move on to the Otto Hoffmann's byproduct oven method. Now in this the oven consists of a number of silica chambers of 10 to 12 meters long and 3 to 4 meters high and 0.4 meter wide, which are placed vertically side by side with vertical ducts in between. These silica chambers have top and bottom opening for the charge and discharge of coal and coke respectively. Now the silica chambers are filled with coal and closed tightly. Below the silica chambers there is one set of checker brickwork which are heat generators. The oven is heated to 1100 to 1200 degrees centigrade by igniting the producer gas or air mixture which is admitted through the inlet. During the firing of the oven, carbonization starts. The flue gases produced as a result of carbonization is partly recycled through the vertical ducts, that is the space, and it is ignited by the preheated generator brickwork. This process is continued for heating the flue gases and is called a regenerative heat system. The carbonization is completed within 18 to 20 hours time. But when compared to beehive, there it takes 3 to 4 days, whereas this is found to be an advantage. The coke produced is raked out and subsequently wet quenched by water spray or by inert gases like nitrogen, which is known as dry quenching. Now, how is the recovery of the byproducts done? So now the coke oven gas produced as a result of carbonization of coal is mainly composed of coal tar, ammonia, naphthalene, benzene, etc. The coke oven gases are produced, or you can say are passed through a cooling tower from the bottom and liquid ammonia is sprayed from the top. The coal tar gets condensed and is collected at the bottom. The remaining gases are then passed through a cooling tower and a fine spray of water from the top results in the condensation of ammonia gas and is obtained as ammonia solution at the bottom. Now again the remaining gases are then passed through a cooling tower where a fine spray of cold water is injected from the top. The naphthalene now gets condensed and is collected at the bottom. Lastly, the remaining gases produced are passed through a cooling tower where a fine spray of petroleum from the top is sprayed, and this results in the condensation of benzene and its homologues, and these are collected at the bottom. The remaining gases are then passed through ferric oxide to recover the hydrogen sulfide gas, which is used as a fuel gas. Now we'll move on to the next topic, petroleum. Now petroleum oil, the primary fuel, is the main source of the secondary fuel. The word petroleum is derived from petra, which means rock, oleum, which means oil. It is known as mineral oil or rock oil. Petroleum is a dark greenish brown oil found deep in the Earth's crust. Chemically, it is a mixture of hydrocarbons such as straight chain alkanes, branched alkanes, cycloalkanes, olefins, organic nitrogen, organic sulfur, organic oxygen compounds, etc. The average composition of petroleum is carbon, which contains 80 to 87 percentage, and hydrogen 11 to 15 percentage, sulfur 0.1 to 3.5 percentage, oxygen 0.1 to 1 percentage, nitrogen 0.4 to 0.9 percentage. So this is the average composition of petroleum. Now let us move on to the origin of petroleum. According to latest theories, petroleum is generated by the decomposition of animal and vegetation mass buried underneath the earth due to natural calamities and for a prolonged time, that is nearly thousands of years, under the action of enormous amount of heat, pressure and anaerobic bacteria, it is converted into petroleum. It is usually found floating over brine above the rock layers. Now we'll see how the refining of petroleum is done. The crude petroleum is a stable emulsion of brine and petroleum oil. Hence, it cannot be used as such. So the unwanted constituents such as the harmful sulfur compounds and other impurities have to be removed, and then it has to be fractionated into desired fractions, which has a different boiling range. The entire process is known as a refining of petroleum. Now, the refining of petroleum generally comprises of three steps. First step is the separation of brine from petroleum. Then second one is separation of harmful sulfur compounds, and the third one is it is subjected to fractional distillation where the various fractions are obtained. Now first let us move on to the separation of brine from petroleum. It is separated by a method called as Cottrell's process. The crude petroleum is a stable emulsion of brine and petroleum oil, and this brine is separated from the petroleum oil by passing the crude petroleum through a pair of highly charged electrodes. In the electric field, the emulsion of oil and water separates out and the petroleum is collected. The second step, that is the separation of harmful sulfur compounds. So in order to remove the sulfur compounds, the petroleum oil is treated with copper oxide. Chemical reaction takes place between the sulfur compounds and the copper oxide, and hence the compound is converted as copper sulfide, and this is precipitated and it can be separated out. Now we are moving on to the most important part, that is the third step, the fractional distillation. The crude petroleum is electrically heated to a temperature of 400 to 450 degrees centigrade in an iron still, which converts it into petroleum vapors having non-volatile residue called the asphalt. These hot vapors are then fed into the fractionating column. The fractionating column is a tall cylindrical tower containing a number of horizontal stainless steel trays kept at a short distance. Now these trays are provided with inlets for the passage of ascending vapors and short chimneys fitted with loose caps. These chimneys provide large surface area to condense the petroleum vapors at different heights of the fractionating columns. Different fractions will be condensed and collected through the outlets. Now this is the pictorial representation of the fractionating column, and we can see how the various fractions are obtained, and it is also represented as a figure, that is the uses of the various fractions. Now we'll just see this in terms of a tabular column. Now here We have just tabulated the various fractions according to the boiling range and the carbon chain length and its uses. The first one is the refinery gas, where it is obtained at a temperature range of minus 160 to minus 5 degrees centigrade. And here the carbon chain length is from 1 to 4, or you can otherwise call as methane, ethane, propane and butane. It is mainly used in the home heating and cooking camping fuel. The next one is the gasoline. This is otherwise called as petrol. Here the boiling range is 40 to 110. The carbon chain length is 5 to 8. 8 is nothing but it is octane, and it is mainly used as car fuel. Then naphtha, it is 110 to 180 degrees centigrade. The carbon chain length is 8 to 10. That the 10th one is called as the decane, and it is used in the making of plastics. Then the kerosene, that's the paraffin, it is obtained at a boiling range of 180 to 260 degrees centigrade. The carbon chain length is 10 to 16, and it is called as dodecane, and it is used as a jet aircraft fuel. The next one is the diesel. It is obtained at a boiling range of 260 to 320 degrees centigrade. The carbon chain length is 16 to 20. It is hexadecane, and it is used as a fuel for buses and lorries. Then the next was the fuel oil, where the temperature is 320 to 400 degree and the carbon chain length is 20 to 50. It is icosane, and it is used in the industrial heating systems. The last product is the bitumen, the residue, or you can say as tar. It is obtained at the boiling range of 400 to 600. The carbon chain length is greater than 50, and the main use is it is used for the surfacing of roads. So this is how the various fractions obtained by the fractional distillation is being tabulated, and it is explained. Thank you.